Okay, I'm going to do something here on number 13 that's not going to work. So just watch what happens here, and I'll show you what's going on here in just a minute. So let's just pretend we move those two things over there like we had done. So I'm going to start with iron. So right there's two of them in that term. There's no iron here. There's no iron there, and there's one iron here, but it would have been moved over, so it would be a -1 over there, and it's equal to 0. Okay, and then let's go with sodium. Got one package of 3, so there's 3 of them. I've got no sodium in any of that. I've got one sodium sitting right there, it'd be on that side, so it's -1, and there's no sodium there. Oxygen, got 4 packages 3 times, so there's 12 sitting there. I've got 3 oxygens 2 times, so there's 6. I've got 4 oxygens over here would be -4, and here I've got 3 oxygens 3 times, so there'd be 9 on the other side. And then Ba, what is that? Basalt maybe? I don't know. None there. Got 1 Ba there. Got 1 there that would be on the other side, and I've got none there. And is that everything? No, we've got a nitrogen still. 0 nitrogens. There's a nitrogen twice. No nitrogens there, but there's a nitrogen 3 times, equal to 0. Okay, 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. Let's get in this 5 by 5 here. Okay, so I've got a 2, 0, 0, -1, 0, 3, 0, -1, 0, 0, 12, 6, -4, -9, 0, 0, 1, -1, 0, 0, 0, 2, 0, -3, and 0. Okay, I've got it in there. Let's take a look at what's happening to that. So I would like the reduced row echelon form of matrix A. Okay, let's see here. So I've got a bunch of zeros there and a bunch of zeros there. So let me jot down just what I have here so I can have some paper to deal with it. So I've got 1, 0, 0, -½ 0. I've got 0, 1, 0, -3 halves, 0, 0, 0, 1, -3 halves, 0. And then the last 2 columns are zeros. Okay, we can just ignore those then. Look, right here's the reduced row echelon diagonal. So I had, here was A, B, C, and D, and then the answer. So this is A, B, C, D, and then the answer. Okay, so I have something right here. So I have C minus 3 halves D equals 0. Okay, so that would be the same as C equals 3 halves D. Here I've got, so there's 1. Here I've got B minus 3 halves D equals 0. So that's B equals 3 halves D. And here I've got A. A equals A minus a half D equals 0. So A is equal to half of D. Okay, so if I were to write all this stuff out then, so the A is a half D, the B was 3 halves D, the C is 3 halves D, and then D. Okay, so the mistake, the problem that I thought we were going to have doesn't seem to be occurring here. So it looks like it can make D 2. So if D is 2 there, that's going to be 3. If D is 2 there, that's going to be 3. And if D is 2 there, that's going to be 1. So it looks like I've got a 1 of these. So I've got 1 Fe to SO4, and then 3 of these BaNO3. And that goes to 3 BaSO4, and 2 FeNO3. Okay, not really fitting it all on there very well. Okay, so to check that, on this side now, there's 3 of the BAs and there's 3 of the BAs. So that's good. I guess I could just go in this order. How about the iron? Okay, there's 2, and that's all. So this side has 2. Does this side have 2? Right there's 2 irons only, so the iron's good. Oxygen. There's 12, and there's 6 more, but there's 3 of them. So there's 6 3 times, so that's 18. And then here was 12. So this side has 30 oxygens. Okay, let's see here. So there's 4, but we have 3 of them. So that's giving us 12. And here's 9, but we have 2 of them. Okay, so that side, so there's 30 oxygens both. How about N? Let's see, no N's there, so there's 2 N's, but we have 3 packages of them, so that's 6. Over here, the nitrogen, there's 3 nitrogens, and there's 2 packages, so there's 6. Well, we're left with sulfur. There's 3, and none here, so there's only 3. What about sulfur over here? There's 1, but we have it 3 times. Okay, so that worked out. So what I want to show you is, do we really have to have this set equal to 0? Okay, so I thought it was actually going to crash, but it didn't crash. Both of these bottom ones, I thought only one of them was going to go away, and it was not going to work out, but it made the bottom 2 go away, and it's still, everything was good. So we can still keep doing what we were doing. However, now I want to show you something. You don't actually have to set these equal to 0. They can stay what they are. They can stay in the same place, because really it's not a math equation. We really would never move this over and then it turns into nothing. That's kind of what we're saying when we move it equal to 0. Well, chemistry is never going to have a combination that turns into nothing. So we really can just leave them the way they are. So let's do this one that way now. So we've got Fe. Okay, well there's 2. There's none. Now since I'm not moving them, I'm just going to call this Fe1, and I'm not going to make it equal to anything. These 2 are equal to those 2, basically. Okay, the sulfur. Well, there's 3. There's none here. There's 1, and there's none there. Oxygen. There's 4 3 times, so that's 12. There's 3 2 times, so that's 6. There's 4, and there's 9. What else we have? Ba, maybe basalt. There's 1 right there, and there's 1 right there. And then we still have nitrogen to deal with. No nitrogens. There's 1 set twice. No nitrogens. And there's 1 set 3 times. Okay, now we have 1, 2, 3, 4, 5. 5 by 4. Okay, so I'm going to put in the 5 by 4. So last time it was a 5 by 5. Okay, 2, got that one in. 0, 0, that's now a 1. 3, 0, that's a positive 1, 0. 12, 6, need that to be positive 4 and positive 9. 0, 1, 1, 0. 0, 2, 0, now I'll make that a positive 3. Okay, so there's the 5 by 4 without the 0 column now. Let's take a look at the reduced row echelon form of that one. Okay, we have something wrong now. So one of the things that happens is if you end up with more 1, 2, 3, 4, 5, and then it only has 4 over, a 5 by 4, that means we have 4 equations and 5, let's see, what do we have? We have 5 equations and 4 unknowns. Okay, that's not going to be able to go to row echelon form. I should have done it. This one's the one that doesn't work. So if you end up with the first number being bigger than the second number, it's not going to work. So if we end up with the first one being bigger than the second one, then we have to add in this extra row of zeros in order for it to get the diagonal set. Okay, now if you have a 5 by 4 and you just want this extra row of zeros, all you've got to do is make it a 5 by 5. And look, by default, it adds an extra column of just zeros. So now we're where we were the way I had it set up in the first place. So there goes what I had over here. So there's the matrix over there, and it turned out to be this one. So now we have what we did at the very beginning. Okay. Let's do number 14. So we already did this one. You can just answer this one as 1, 3, 3, 2. Now really I don't want you to answer it like that. We need to put it up here so there's one of those. So really the answer is one of those, 3 of these, 3 of these, and 2 of those things. That's what chemistry is really looking for now. So we're using our calculator to help us find those, but the actual answer is to put those values up there. Okay, let's see how 14 works out. All right, so I'm not going to put the extra column of zeros unless I need it. So I've got some potassiums here. So we've got 4 of them there, 4 of them there, and 2 of them there. And I've got oxygens. 6 of them here, 0 of them here, and 4 of them here. Now this looks like it might be easy, but if we were trying to do that by hand, it's hard to get 6 and 4 to match up. Well, actually, since the oxygens are also 6 and 4, this one probably wouldn't be that hard to do it by hand. But now that we have such a fast way to deal with it, let's just put in the 2 by 3. Okay. 2 by 3, and so now it goes so fast. We've done all the thinking, now we just pretty much do the mechanics. Okay, fractions are almost always easier to deal with here. Okay, so there we have it. So right here, remember so I'll jot it down up here. So what this has given us is 1, 0, 2/3, and then 0, 1, negative 1/6. Here's the reduced echelon form. This was A, B, C. Now see, we didn't make it equal to anything. So that was the A, that's the B, and that's the C. So look what I've got right here. I've got, let's see. We could think about it as it's equal to 0, but here is the relationship. Now, if we're not going to get too hung up on negatives, then everything is okay. I can say, really what this is saying is B minus 1/6 C is 0. Okay, so B is 1/6 of C. And then this one is saying A plus 2/3 of C equals 0. So A is negative 2/3 of C. Now that negative right there sometimes is an issue. But what we're going to do is we're going to treat that as a negative. Later on a harder one, that negative is going to matter, and I'll show you how it matters. But right now, it doesn't matter. So, and I'll show you why. We just want the absolute values of those. So here's our little answer set. We've got negative 2/3 of C. The second one is 1/6 of C, and the third one is just C. So if I let C be 6, this one now is 1. And if this is a 6, 2/3 times 6, the 3 will cancel that down, and this will become a -4. Now, it's the absolute value of all of those. So really now, at the end, it's the absolute value of that. So it's going to be 416. So I have 4 of these, 1 of these, and 6 of those. So there's our answer set. Now for each of these, I do want you to go back and check it. So I'm going to go with the potassiums. See, on this side, I've got 4 packages of 4, so this side has 16. There's 6 times 2 is 12, so there's 12 of them and 4 more, so the potassiums are 16 each. And then the oxygens. I've got 4 sets of 6, so the oxygens on this side is 24. And here I've got 6 sets of 4, so the oxygens on that side are 24. So we have it, we have a check. 15. Now we can go pretty fast, I think, I hope. So I've got potassium. 4 there, 0 there, 1 there. There's 1 P. Oxygen. Okay, I've got 10 here, 1 here, and 4 here. And then hydrogen. No hydrogens there, 2 hydrogens there, and 3 hydrogens there. Okay, now we can just go fast. Second matrix, edit. I have a 3 by 3. I may or may not need that extra set of zeros. On a 3 by 3, let's take a look and see what we have here. So 3 by 3, we've got 4, 0, 1, 10, 1, 4, 0, 2, 3. Reduce that thing down as some fractions. Okay, so that one turned out nicely. So I've got 1, 0, 2/3. And I've got 0, 1, -1/6. Okay, so there's the reduced row. So here's 1b minus 1/6 c equals 0. And up here I have a plus 2/3 c equals 0. So b is 1/6, a is 2/3. -2/3. So the a is -2/3 c, the b is 1/6 c, and then c. I'm just going to pick a whole number that makes all of them whole numbers. So it looks like 6 again. So 6 in there makes that one 1. If I stick a 6 in there, that gives me a -2, and I want the absolute value of that. So this is a 216. I need 2 of those, 1 of those, and 6 of these. That's how we would answer them. Okay, checking. I have some potassium. Right there is 8. So there's 8 potassium on this side. This side, looks like I only have 6. That's not good. This potassium, there's 6 of them. Okay, it doesn't look like we got that thing balanced. Let's see what else happens. What else did we have? Oxygens. I have 2 sets of 10 for 20. And here I have 6 sets of 4 for 24. Things are not looking good. And then hydrogen. Here I have 1 package of 2. And here I have 6 packages of 3. Okay, that's definitely a problem. Okay, well that's why we check it. So I had to go back and take a look at the video. So here's the matrix, 4, 0, 1, 10, 1, 4, 0, 2, 3. That all looks good. But I'm pretty sure when I did that, all I did was say math fraction, and it gave me the previous answer. So let's just type it in again. I need math, row echelon form of matrix A, and check that out again here. Okay, there we have it. Now I'll go math fraction. So everything was in right, just didn't push all the buttons. So there it is. It's So let me adjust what we have here. It's 0, 1, 1/4. So right here was 1/4. If I have a different color here real quick. Oh well, we'll have to deal with it. So that was 1/4. And then the other one was 3/2. So this was a 3/2. So this part was B plus 3/2 equals C. And this part was A plus 1/4 equals C. So our A term, when I move the A over here, that will be negative 1/4 C. Moving the B term over here, that will be negative 3/2 C and then C. Now, just as an observation, these negatives are just saying that these two things are on the opposite side of the balance bar of this one. So these two are on the opposite side of this one, which makes sense. They're over here and the C term is over here. Okay, so now instead I'll just make C 4. Okay, if C is 4, here we had the 2, that'll make this a negative 6, and that'll make this a negative 1, and now we want the absolute values of all of those. So our actual answer should have been 1 P4O10, 6 waters, and then that will give us 4 of these H3PO4s. Now let's test it out. Let's take a look at this potassium. There's 4 once, so that's 4 of them, and none here. So the potassium on this side is actually 4. There's 1 potassium 4 times. So now our potassium is 4 and 4. So the potassium is balanced. What about oxygen? There's 10 once, and there's 1 6 times. So I've got 10 of them from here and 6 of them from there. So this side looks like has 16, and there's 4 of them happening 4 times. So the oxygens are also balanced at 16. And now the hydrogens. Okay, there's 2 6 times, so there's 12 of them over here. And there's 3 4 times, so there's 12 of them over here. So here's our balance set, and here's the balanced equation. Okay, let's take a look at number 16. So it looks like I've got, that's a lowercase l, so that's AL. Not sure what that, maybe that's aluminum, but I'm not sure. Okay, so there's 1 of them here. That 3 is just for those. So there's 1 there, there's none of them there, there's 2 of them here, and there's none of them here. Then I've got oxygen. There's a set of 3. There's 4. There's 4 3 times, so that's 12, and there's 1 more. Now this would be hard to do by hand. If I've got 12 of them on this side and 13 to do on that side, that looks like a difficult one to do by hand. Hydrogens, here's 3. Here's 2. So this side has 5. Hydrogens, there's none there, and there's 2 there. So I got a 12 against 13 oxygens and a 5 against 2 hydrogens. That's not a simple balance. Sulfur, no sulfur, 1 sulfur, 3 sulfurs, and no sulfurs. Okay, do we have anything else? HOSAL. So I've got a 4 by 1, 2, 3, 4. Let's type that one in. This time, so I've got a 4 by 4. 1, 0, 2, 0, 3, 4, 12, 1, 3, 2, 0, 2, 0, 1, 3, 0. Get the reduced of that one. Okay, so everything is good. We've got the bottom row dropping out. So it's 1/3, 1/2, negative 1/6. So we've got 0, 1, 0, 0, 1/3. I've got 0, 1, 0, 1/2, and we have 0, 0, 1, negative 1/6. So A, B, C, D. Here's a relationship right there. C minus 1/6 D. Here's B with D, so B plus 1/2 D. And here I have A plus 1/3 D. So my relationship then is A, if I move the D to the other side, is negative 1/3 D. B will be negative 1/2 D. Move this to the other side, will be 1/6 D and D. So see how these two are positive, they're on the same side, that's representing those two, and these two are negative, that's representing the other side. So it looks like if I just make D6, that's 1/6 times 6 will make this one a 1. Negative 1/2 times 6 will make that a negative 3, and this one a negative 2, but we want the absolute values of those. Okay, so this one gets 2. There's 3 of these. There's 3 of these. Oh no, there's 1 of these, that was a 1. And then there's 6 of waters. Okay, so let's make sure it balances. AL over here, there's 2. And right there's 1 package of this, so there's 1 of these sets of 2. So it's 2 and 2. The oxygen, okay, there's 2. First of all, there's a set of 3 of them right there, but then there's 2 of them, so that's 6. And then there's 4 at a set of 3, so that's 12. So we've got 6 and 12. So there's 18 oxygens over there. Okay, there's 12 oxygens and 6 singles. So there's 12 and 6 for 18 over there. So things are going well. Hydrogen. Okay, there's 3 of them twice. That's 6. And there's 2 of them 3 times. So I've got 6 and 6 for 12 of those. Hydrogens, there's 12 and none there. So hydrogens are good. And sulfurs, none there. So I've got 3 singles, so that's 3. And here we've got a package of 3, so that's 3. So the sulfurs are 3 against 3. So there's the set of elements, and here's the balance. '17 has a couple little new notations, but basically it's the same, it's just longer. This would be quite a bear to probably put together by hand. So now that we have a little aid, as long as we know, keep everything straight, and we know how to use matrices on our calculators, we can make this happen pretty nicely. Fe. Okay, let's see. I've got 1 right there. Now, what this means is, this is a large molecule that's this compound with this connected to it. So this is all one molecule right here. So this whole thing has only one Fe in it. Just like this is a molecule. So the molecules are separated by these pluses. So there's no Fe's there, there's 0 there, there's 0 there. And here it is again. See, it's the K3 times all of this, and then all of that times 3 more waters. So this is one piece. Okay, well, it looks like there's just one Fe in there because that 3 is connected to those parentheses. So there's 1, I think Fe is iron, so there's 1 iron in all of that. Okay, carbon. There's 2, so out of all of that, there's just those 2. There's 2. There's none there. There's 2. And on this piece over here, there's 2 of them 3 times, so there's a total of 6. Let's look for oxygen next. So the oxygens in all of this, now this is all one piece, so there's 4 of them there, and then there's a single twice. So there's 4 and there's 2 more oxygens, so that molecule has 6 total. All right, oxygens right here, well there's 4. Oxygens right there is 2. Oxygens right there is 4. Okay, let's count them up here. So there's 4, There's 4 sets of 3, so there's 12. And then here's 3 more singles, so those 12 plus 3 more, so there's 15 oxygens in that piece. Okay, hydrogens, there's a pair doubled, so there's 4 total. There's 2, there's 2 more, there's none in that section. Okay, let's find the hydrogens here. So there's none there, but there's a double 3 times, so there's 6. And the last one, K. No K's there. No K. There's none there. Looks like there's 2 sitting right there. Okay, there's 3 of them. Okay, is that everybody? 1, 2, 3, 4, 5. We have 5 elements and 1, 2, 3, 4, 5. So it looks like we've got a 5 by 5. Okay, well let's see what happens with that. So that 5 by 5, put in all of those numbers. So we've got 1, 0, 0, 0, 1, 2, 2, 0, 2, 6, 6, 4, 2, 4, 15, 4, 2, 2, 0, 6, and 0, 0, 0, 2, 3. Go down and get my reduced row echelon form of matrix A. Okay, so the last column went away again, so that's good because we need it to be relative, so that's a good sign. So I'm going to go math, fraction, and get that, jot this fraction thing down here. So here's what I have now. 1, 0, 0, 0, 1. 0, 1, 0, 0, 1 half, 0, 0, 1, 0, 1 half, 0, 0, 0, 1, 3 halves, and then the rest was a bunch of zeros. Okay, A, B, C, D, E basically equals 0. Okay. So this spot right here is the D spot. So that's telling us D plus 3 halves E equals 0. This one is C plus a half E equals 0. This one's the B plus a half E equals 0. This one's A plus E, 1E equals 0. So there's the relationship. D is negative 3 halves E. C is negative 1 half E. B is negative 1 half E. A is negative E. So the relationship then is A is negative E. The second spot is negative half of an E. The third spot is negative half of an E. The fourth spot is negative 3 halves of an E, and then we get to pick E. Okay, so what this is saying is, see, all of these are negative. Well, that's saying all of those are on the same side, and this one's on the other side. There's only one term over here, that's the E, and then all the other ones are on the other side. So that makes sense that we have a negative there. Okay, well, let's see. It looks like I need to pick E as 2, and all those fractions will become whole numbers. So that's going to make this one negative 3. It's going to make this one negative 1. It's going to make this one negative 1. It's going to make this one negative 2. Now, all those negatives means is they're on the other side of the arrow, the balance arrow, as this one. So I don't really care. I'm just going to take the absolute value of all of those. So there's the relationship. 2, 1, 1, 3, 2. So 2 of these, 1 of those, 1 of those, 3 of these gives us 2 of that thing. Okay, that's the balance. Oh, I hope it balanced. Maybe I shouldn't have circled that in until I've checked them all. So let's come over here now. I'm gonna get me the element list. So, did we get it to balance? There's an FE twice. So this side has 2. On this side, there's an FE twice. So that one checks out. Let's do carbon next. Okay, there's some carbon right here and right here, so let's take a look at it. There's 2 of them twice, so far there's 4. And then over here there's 2 of them once, so that's 2 more, so I've got 4 and 2. So the carbons over here are 6. What about the carbons over here? There's 2 of them 3 times, so that's 6 of them, but then it's doubled. So it looks like there's 12 on this side. I'm probably just missed something over here. So there was 4. There's 2 more is 6. Oh, sure enough, I missed these. There's 2, 3 times, that's 6 more. So I had 6 and there's 6 more. So it looks like the carbons are 12. Oxygen. There's 4 twice, so that's 8. Now, this 2 is on all of this, so let me count it. There's 4, and then there's 2 more. So there's really 6 oxygens in this piece that's been doubled. So 6 doubled, so that's 12 out of this first piece. Oxygens here, there's 4 more. I'm going to jot that down as 4 more. Oxygens here, there's 2 more. Oxygens here, there's 4, 3 times, so that's 12 more. So it looks like the oxygens on this side are 12 and 12 is 24, 25, 26. So it looks like to me there's 30 oxygens on that side. Let's see if there's 30 over here. So there's 2 of this big, this, oh, excuse me. There's 2 of these. So there's 12. And then 3 more for 15, doubled. So sure enough, there's 30 oxygens on that side. What about hydrogen? Okay, there's probably lots of hydrogen. So there's 4 that have been doubled. So 4 that have been doubled is 8. I'm just gonna keep a running total like I did last time. There's 2 more, and there's 2 more. So 8 plus 2 plus 2. So it looks like there's a grand total of 12. Are there 12 on this side? Okay, well there's 6, and that whole molecule's been doubled. And the last one, I'll put the K up here. Well, there's none there, there's none there. There's only some K's right in this spot. So there's 2 of them 3 times, so that's 6. And over here, there's 3 of them 2 times, so that's 6. So there's our element list. Everybody is balanced. All right, 18 looks a little bit shorter. Now, if we had to do this by hand, though, trying to get this 7 to go to a 1, I got a 7 and a 1. Then for oxygens, I got 4 against 3. That's hard. Hydrogens, 6 against 2. So it would probably, these are weird numbers to try to get common. But we don't care with our matrix. The matrix doesn't care how how ugly they are, how far apart they are. Here are the carbons. There's 7, there's none, there's 1, and there's none. The hydrogens, there's 6, there's 0, there's 2. The oxygens, there's 2, there's 2, there's 2, and there's 1. Okay, I'll let my magic machine do the rest. Okay, it's a 3 down and 4 across, so it's a 3 by 4. I'll get those numbers in there quick. 7 0 1 0 6 0 0 2 2 2 2 1. Okay, reduced row echelon form as a fraction. Okay, there we have it. So I've got 1 0 0 1/3, 0 1 0 5 halves, and 0 0 1 -7/3. So there's the row echelon diagonal. A, B, C, D equals 0. So this one right here is telling us that C minus 7/3 D equals 0. This one is telling us that B plus 5 halves D equals 0. And this one is telling us A plus 1/3 D equals 0. So my first number relationship, if I'll take this 1/3 and move it to the other side, so it'd be -1/3 D. Taking this and moving it to the other side gives me -5 halves D. Taking this 7/3 and moving it to the other side gives me +7/3 D, and then I have D. So these two negatives are on this side, these two positives are on this side. So far, so good. Looks like if I pick a 6, they'll all become integers. So if I pick a 6, that'll be 2 times 7. If I pick a 6 here, that'll be 3 times 5. If I pick a 6 here, it'll be -2, and I want the absolute value. So 2, 15, 14, 6. So I've got 2 of these. 15 oxygen dioxides. 14 carbon dioxides, and 6 waters. Okay, there's the balance. And let's get the element list. Carbon. There's 7 twice for 14. So that's it, 14. Over here, there's 14 right there, 14 singles, and that's it. So the carbons are 14. Hydrogen. There's 6 doubled, so it looks like that's 12 with no more. Over here, there's 2 hydrogens times 6, so it looks like there's 12 hydrogens. Oxygen. Okay, there's 2 doubled, so it looks like there's 4 out of that piece, and then 15 doubled. So there's 30, and then those 4. So it looks like there's 34. Are there 34 over here? There's 14 pairs, so that's 28, and then these 6 more singles. So 28 and 6 singles is 34. All right, 19 should be a quick one. Sulfur 801. Oxygen 023. There it is. Got to get that in reduced row echelon. Two down and 3 over, so 2 by 3. 8 0 1 0 2 3. So 1/8. So I've got 1 0 1/8 and 0 1 3 halves. There's my diagonal. Oops, sorry. There's my diagonal. So A, B, C equals 0. So right here I've got B plus 3 halves C equals 0. And up here I've got A plus 1/8 C equals 0. So moving the 1/8 to the other side, so I have negative 1/8 C in the first spot. Moving this one to the other side, negative 3 halves C in the second spot. And C is the one that I get to choose. These are on the same side, which, yes, they are. So if I take 8 as the multiplier, that's going to make this 3 times 4. And that's going to make this one just negative 1. Okay, the negatives only mean which side they're on, so I want 1 of those, 12 of those, and 8 of these. So 1 of that, 12 dioxides, and 8 sulfur trioxides. So the element list, sulfur, this side has 8. This side has 8 singles for 8. Oxygen. Looks like there's 12 pairs, so 24. And here there's 3, but 8 of them, so 24. Okay, the last one would be very intimidating if it were not for our matrix idea. So now that we have this matrix idea, all we got to do is be careful to count them up, be careful to enter them in the calculator, and then do the relationship. So let's just start with the K's. This whole piece has 3 K's. Looks like there's none there, 0 there, 0, 0, 0, 0. There's 1 and 0. Okay, how about FE? There's 1, that 6 goes to those 3, but not the FE, so there's only 1, 0, 0, 0, 0. Okay, there's 1, that 3 goes to this piece, so there's only 1, 0, 0, 0. Sulfur. Okay, now this parentheses has 6 of them, so there's a single 6 times. Sulfur, none. There's a sulfur right there for 1. There's none there. Okay, there's a single 3 times. None, 0, 0. And there's a sulfur just once. Carbon. There's a single 6 times. 6. This is a small r. That's not carbon, that's CR. When there's a small letter, they go together. So that is not carbon. No carbon. There's 1 right there. That's the CR again, so no carbon, no carbon, no carbon, no carbon, no carbon. Nitrogen. There's a single 6 times. Same thing, that's sodium, that's not nitrogen. That small a goes with that, so that's 0 nitrogen, 0, 0, 0. There's a single 3 times for 3. 0. There's a single just sitting there, 1, and then there's none there. How about what's next? Sodium. Na, that would be that one. So there's no sodiums in any of that, but there's 2 of them there. 0, 0, 0, 0, 0, 0, and there's 2 of them there. CR, I don't know what CR is, cranium or something like that. None there, but there's 2 of them. 0, 0. There's 2 of them. 0, 0, 0, 0. Oxygen, none there. Okay, there's 7. There's 4. There's 2. There's 4 3 times for 12. There's 3 3 times for 9. There's an oxygen. There's 3 of them. And there's 4 of them. Lots of oxygens. Hydrogen. Got 0 there. We have 0 there. We have 2 right there. 0 hydrogen, 0, 0. There's 2. 0 and 0. Okay, if I didn't make a mistake, then I just got to get it in my calculator. So get this thing turned on and get them typed in. So we have, how many down do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9 down. And how many over? 1, 2, 3, 4, 5, 6, 7, 8, 9 across. So it looks like we got a 9 by 9. 81 numbers. Okay, well, let's just get them in. I won't call them out. I'll just type them in. Okay, there we go. See what it says. Well, that looks kind of nice. I'm going to math fraction that. Okay, so see if I can get all this stuff on the calculator at once. So let's see. I'm not going to write all this matrix down now. A, B, C, D, E, F, G, H, I. So that's A being related to I. So I've got A plus 1/16 I equals 0. This is, they're all related to I. So the next one will be B plus 1I equals 0. Here's the C and 29/8. So C plus 29/8 I equals 0. D is the negative 3/8. So D minus 3/8 I equals 0. A, B, C, D, E. So here's the E, which is the negative 1. So E minus 1I equals 0. F. So F is right here with the 16. So F minus 1/16 I equals 0. Okay, so I'm going to push down, hit the down arrow. So here's the G. G is the negative 29/8, so G minus 29/8 I equals 0. There should be one more for H. And there it is, H and negative 3/16. So H minus 3/16 I equals 0. Okay, let's put all that together. So the A spot. The first spot is right there. Move the 16 over, so that'd be negative 1/16 I. B, move the I over, negative I. C, move the 29/8 over, negative 29/8 I. The D, move the 3/8 over, so that'll be 3/8 I. E, move the I over, that'll just be I. F, move the 1/16 over, so 1/16 I. G, move the 29/8 over, so it'll be 29/8 I. H, move the 3/16 over, so that'll be 3/16 I, and then I get to pick I. So what it's saying is 1, 2, 3, 4, 5, these last 6 things are on one side. 1, 2, 3, 4, 5, 6 are on that side, and these negatives, 3 negatives on the other side. 1, 2, 3. So I'm pretty happy with that. Okay, it looks like the common denominator is 16, so I'm going to choose 16. Okay, if that's 16, this one's 3. That makes this 29 times 2, so 58. 16, 1/16 of 16 is 1. This I right here is 16. This will be 3 times 2, so that'll be 6. 29/8 times 16 will be negative 58. That's just the 16. And that will be negative 1. Okay, I want the absolute values of those. These negatives just means they're all on the left side. Okay, so for the balance, it's saying I've got 1 of these, 16 of these, 58 of those, 6 of these carbon dioxides, 16 of that thing, 1 of these, 58 waters, 3 of those, and 16 of this last thing. There's the balance. All right, and lastly, I want to see if how they all balance. I think I'm just going to put them right here, the K's. Okay, this side, there's 3 K's and no more. This side over here, right here they are 3 singles. So it looks like K is 3. The irons. Okay, I've got 1 iron, and that's it. The next iron is right here. There's 1. So there's only 1 iron. Sulfurs, okay. There's 6 of them here one time, so there's 6. Let's see, where's the balance equation? Right there. So there's 6 sulfurs. And here's 1 more 58 times. So 58 and 6 is what, 64? So there's 64 sulfurs on that side. Where are they over here? So there's 3 of them, 16 times. So that's 48 of them. And here's 1, 16 more times. So 48 plus 16 is 64. Carbon. Okay, there's 6. So this side has 6. There's a single 6 times, and that's all there is. Nitrogens. There's 6. That's all there is. So right here's some nitrogens. So there's a single 3 times, and there's a single 3 times. So 3 and 3, 6. Things are working out well. Sodiums. Okay, there's 2 of them, 16 times, so there's 32 of them. Here's the other sodium, 2 of them, 16 times. So there's 32 sodiums on both sides. The CRs, there's 2 of them 16 times, so 32 of them. The rest of them are right here. There's 2 of them 16 times. Oxygens, okay, there's 7 of them 16 times. So 7 of them 16 times is 112. And here's 4 of them 48 times. That's 192. So 112 and 192. It looks like there's 300 and something of those. 304 oxygens on this side. Wow, are we going to get 304 on this side? Okay, there's 2 times 6. There's 12 of them 16 times. I'm just writing these down on my calculator as we go. Okay, here's 9 of them 1 time, so plus 9 more. Here's 1 of them 58 times, so 58 more. Here's 3 of them 3 times, so 9 more. And here's 4 of them 16 times, so 64 more. Add all that up. $304. Oxygens, I think that's 304. I'm going to go with that. Let me check one more thing. It might be 344. Here's 7 times 16, and here's 4 times 58. Yeah, it's 344. Okay, now I'm a little happier. And hydrogens. I've got 2 of them right there, 58 times. So it looks like there's 116 hydrogens. And over on this side, right here's the 2. I've got 2 of them right there at 58, so also 116. So there's the element list. The balance and the element list. Okay, so there we have it.